Hi, my name is Doug, and welcome to Emerald Hills Skies. Tonight it's kind of an impromptu session. We didn't notify anybody that we would be doing this, but it was just really fun for me to come here and take my time and work through the paces. We've got a new scope that we're trying to learn how to use. Here's a live view of the scope. It's about 200 feet out there in a field in the 35-degree winter. And I'm nice and toasty inside what you might call a control room here at Emerald Hills. It's actually my office where I work each day. And through a 200-foot Cat 7 cable, we're able to not only to control the scope, but to see what it's seeing as well. Tonight's been a fun night. I've been working my way through several targets. Right now, I'm looking at the planet Uranus. And if you've never had a chance to look at Uranus, then this is a chance you could take right now. Here's our planetarium software. We use an app called Sky Safari. And if you were to go outside right now and look due south, and then work your way maybe about 2/3 of the way up the sky toward the zenith, but not quite to the zenith, you would see the planet Uranus if you had some really good eyes. You can see it's pretty dim right now. Let's see what magnitude it is these days. 5.6. So it would be at the limit of your visual magnitude that you could see. Now let's go see it. How about that? This is a live view through that telescope that you see over there to the right. And right there in the middle, you can see Uranus. Now, to get your bearings in the sky, let's go back to our planetarium software and let's kind of zoom in on what we can see. We should be able to see the two moons, Titania and Oberon. And if we're lucky, we might be able to make out Miranda here on the top side. If we're super lucky, we might be able to see Umbriel on the bottom. Okay, so let's go back to our live view. We're using SharpCap to be able to view through our RASA 11, which, like I say, is out there in the field. This RASA 11 is sitting on top of an Ioptron CEM70G mount. That's the hunk of metal that points the tube, the RASA 11 optical tube assembly. And this CEM70G mount is very accurate, so it can point the telescope exactly in the right place. So I'm going to go over to SharpCap now and zoom in just oh, that's probably far enough. Look, here are those two moons. Titania and Oberon. Titania and Oberon are here on either side. And then Miranda is the one that's just so close to the disk. And I think this might actually be this little galaxy, PGC 1476215. I don't think that's one of the moons. I think this little moon is just barely visible on the edge of the planet's surface. It's kind of hard to do this balancing act when the moons are so close, comparatively speaking, to the planet. We kind of have to wait till they're farther away, like these two. Again, Titania and Oberon. Titania and Oberon here. So this is Uranus, and it's kind of fun to see it now. If you're interested, we're taking 5-second exposures through this RASA 11, and we're at gain 400. So it really, makes the planet pop. And every 5 seconds, the image refreshes. So these are live views. This is not stacking. You've heard of the concept of stacking lots of views on top, so it maybe eventually increases the signal to noise ratio. With this RASA 11, we're fortunate tonight. We're able to use 5-second single shot images. So let's save a snapshot of this. And then what we can do is go over to our targeting software, which is called Astroplanner. And in astroplanner, let's just do a quick note of what we saw. So we're going to say make an observation, and we're going to say we were able to see, we saw Uranus and 3 moons, and again those moons were Titania, Oberon, and Miranda. Titania, Oberon, and Miranda. We also saw PGC 1476-215 nearby. Now what we'll do is we'll go up here under attachments, and you might not see me adding this file because it opens up a new window, and I have this set so that it's focusing by window. But let's add Uranus's view here, and you might see it pop onto the screen there. So this will be a recording of what we saw. Now, I tell you what else I'd like for us to do. Let's go see if we can chase a comet. And the comet that we're after is Comet 67P. Now, you probably know we're going to, by the way, go ahead and move the scope toward that comet. And you should be able to see the scope moving. In fact, let me just make it a little bit bigger here for you. There's the scope. Again, it's the RASA 11, and has in front of it that black section that's on the very tip. You might not be able to see it in the night sky. It doesn't really stand out, but there's a dew shield. Behind the dew shield, there's a little band around the front of the scope. This band right here is what's keeping the corrector plate from covering up in dew. Now you ought to be able to see a little glare on the dew shield there. I can't see that little band of the dew zapper, the dew buster band there to try to keep dew from forming on the corrector plate. But now you can see the saddle, the dovetail bar here, and it's mounted on this saddle, and you can see the mount here, the Ioptron CEM70G mount. Okay, so let's go back to SharpCap now. This is Comet 67P. So let's go back to SharpCap, and let's change the name right away before I forget. Comet 67P, and we're zoomed in quite a bit now. Why don't we go back out to full view, and just to make sure that we're well oriented in the night sky, let's do what's called plate solving. That'll take a picture of all of these stars and compare it to a library of pictures of stars. We were off about 0.2 of a degree, and that's not really that uncommon after you've traveled that much of the sky. So it'll make this 0.2 of a degree correction, and then it will also add that correction to the brain of the mount, so the mount can keep us on track. Okay, so now we're going to try to find this comet. Let's zoom in a little bit. Let's don't zoom in very much yet, and let's start looking around here. Oh, I see it. Can you see it? It's right there. And I'm going to just visually center it a little bit in our frame. There we go. Let's zoom in a little more now. In fact, I think we can go in and zoom in at 100%. Yeah, there's a comet. Can you see how all the stars are just kind of sharp as a tack, and they've got well-defined edges. But look how this comet 67P, it kind of looks fuzzy, doesn't it? That's what the famous comet watcher Messier was looking for, And when he would look for night sky objects that were when he would see fuzzy night sky objects, deep sky objects, he would wonder if they were a comet, and he would follow them for a while to see if they moved, and if they didn't move, then he wasn't very interested in them, and he made a list of them. And you've heard this story before, I'm sure. The list he made became known as the Messier catalog of deep sky objects, and it was basically a list of what he didn't want to mess around with because he was looking for these comets. And sure enough, this one's pretty fuzzy. Now the RASA that we're using has a very wide field. It's not really designed for comet hunting. I guess you need a wide field telescope to see the big picture, though. That would be good. But then to be able to zoom in on a comet, it's kind of difficult. So what I've done is, a while ago, before we went over and looked at Uranus, I went and took a couple of pictures of this comet. And let me see if I can find those for you. Okay, I think I found them here. I'm going to A-B back and forth. So there's 1226 and there's 1236. Again, 1226 and 1236. So that gives you the dot to watch. If you could keep watching that dot, you see the first picture I took at 1226 a.m. The second I took at 1236. So this is how far the comet traveled in just 10 minutes. You can see the mound is tracking the movement of the stars, but the comet is traveling faster than the night sky. So it is the kind of thing that stands out, and you can see it's a little bit fuzzy as well. So it's very interesting, and I'm really thankful that you're here with us. Those were images that I took about an hour and a half ago or so. But now let's go back to SharpCap. Let me make sure you're seeing SharpCap. Yes. Let's go back to SharpCap. And there is this comet. It has continued to move. And what let's do is let's take a snapshot of it right now. And the other thing let's do, let's see if we can maybe tweak it a little bit and see a little more tail. And what we'll do is we'll just line up we'll just tweak and push all we can before the sky glow of Louisville, Kentucky starts popping in. Okay, right there, you see how the whole image is turning now. Too much sky glow. So let's dip this mid adjustment just below the sky glow. Right there. Now you see the comet glow is a lot bigger. And it's not really a tail that you might see in a classic comet. This comet's not making a tail. At least it's not for us tonight. Now maybe in a very, very dark sky, there might be a tail visible. But here on the outskirts of Louisville, Kentucky, with what they call Bortle 5 or Bortle 6 skies, we try to classify the night sky in terms of how much light dome there is caused by the city lights, sky glow, light pollution. We try to classify it, and we use a thing called a Bortle rating, and our sky here at Emerald Hills is somewhere around Bortle 5 or Bortle 6. Now, maybe if you were in a Bortle 0 sky, you might be able to see a telltale comet tail. But right now, what we're seeing is just a fuzziness around this object. That's just basically the icy glow. And I thought it might be interesting to look at some of the research that's been done on this comet. In fact, this comet happens to be one of the most famous comets ever. Why? Because it's called Comet 67P Churyumov Gerasimenko. And that name should be familiar to you if you've been following astronomy. It was discovered back in 1969. And actually the first images that were taken of it were in Almaty, Kazakhstan. Back then it was in the Kazakh Soviet Socialist Republic, because the Soviet Union hadn't broken up yet. Those images were actually of another comet that were in the picture. But a very sharp observer, his name was Churyumov, studied Gerasimenko's images. And he found, using this blink method that we just used, he found another comet, Comet 67P, on the edge of Gerasimenko's pictures that she had taken in Kazakhstan, in Almaty, Kazakh Soviet Socialist Republic. So he discovered this comet in '69. Now you might be wondering, well, why is this image so close up, and why can't we see an image that close up? Because this image was taken with a spacecraft, the Rosetta spacecraft. And by the time they were done, the Rosetta spacecraft actually landed a lander onto the comet's surface. And what you're seeing here, I hope you're seeing it. Yes, what you're seeing here in this animation, this is a series of still pictures that the lander took while it was on the surface. And you can see it just looks like a Arctic snowstorm there, doesn't it? That's actually on the surface of the very comet that we're seeing right here in our picture. Isn't that amazing that we're able to see the very same comet now years later? Let's go back there, and you'll also see that what basically this comet does is it kind of like what would you call this? It's just sort of rotates in orbit. It's like random, being the way you throw oblong rock through the air. Some of the images remind me of a duck. If you kind of turn your head sideways, you can see it there. And others have observed that too. But other images kind of just look like a rock that has two lobes. You see how it has two lobes? And boy, this Rosetta spacecraft gave us an amazing view of this comet. This Rosetta gave us these views around 2015. And it's worth looking this up. You can look up this very article in Wikipedia, Comet 67P. Let's go back and look at it one more time. Here we are now. This is the live view again. And here is that fuzzy object. Now you notice we're not stacking these images. Again, we're using an exposure time of just 5 seconds. So it's as if the shutter is open for 5 seconds on the camera we're using, and our camera is a ZWO ASI 2600 MC Pro. So it's a special astronomical camera. It's made for astronomy, and it's cooled. Of course, on a night when it's 35 degrees, it's a lot easier to cool it. But we keep it around 8 degrees below 0 centigrade, so we always get the same image value from it. And that way we can make special darks and flats, they're called. There are two different kinds of calibration frames that allow us to tune the camera really precisely so that it tunes out more noise and artifacts. So we've got the darks and flats running now, and this Astro camera is opening up its shutter, so to speak. It doesn't really have a shutter, but if it had a classical shutter, it's a good metaphor, for 5 seconds to take this image at a gain of 400. Gain is kind of like ISO in the single lens reflex old-fashioned camera world. ISO, ASA we used to call it in photography. ISO is a measure of how sensitive the sensor is on your snapshot camera, perhaps. So it's gain 400 at 5 seconds. And say goodbye now. This is the last time we might see Comet 67P for a while. It actually is the closest to Earth right now in its path over the next 6 years. It won't be this close again. It'll go back out now on a very, very distant orbit out by Jupiter, let's say. And this is the closest it will be tonight and tomorrow night. Well, thanks for joining us in our RASA 11 tonight. Thanks for tuning in, and it's been great having you. I hope you can see us again on Emerald Hill Skies. If you like this kind of content, I hope you'll subscribe. It doesn't cost you anything, and it's a great way to kind of boost the channel so others can see it as well. We don't get any income from it, but it's a great way so that when we invest late nights, like now it's about 2 a.m., it's a great way that you can give something back to the channel. So we hope you'll subscribe, and also we hope you'll come back, maybe give it a thumbs up if you like this kind of content. Let us know your questions about comets or planets like Uranus. Let us know your questions, and we'll look forward to being back here another night here at Emerald Hill Skies, and just appreciate you being willing to tune in and watch this recording so that you can be with us. One more thing I'd like to do is just see if by chance did anybody stop by live, and we'll see if you're there. It looks like nobody stopped by live, but you know, it's no wonder because it's 2 a.m. in the middle of the night. But I hope that you were able to stop and see this recording. And if you're watching it now, it means you did, and thanks for watching it to the end. Thanks to God who made these amazing celestial bodies that we can monitor and enjoy and be able to take in here in the skies over Emerald Hills on the outskirts of Louisville, Kentucky.